finishing up section 1.4. Just have a couple problems left. Hopefully it doesn't take us too long. I think these ones are a little bit easier than the nutrition label. So we have the definition for a ratio and a rate. Go ahead, review that if you'd like to, before jumping right into question 8 and 9. So including units in a ratio can help you decide which quantity should go in the numerator and which one should go in the denominator. Remember, numerator is on top, denominator is on the bottom. If you need help remembering that, numerator on top, denominator on bottom, it's no duh. And my weird 7th grade teacher taught me that, and for some reason that just really stuck with me. I still use it to this day because I never remember which one is the numerator, which one's the denominator. I always go no duh and figure it out that way. So quick little trick. Maybe it'll help you down the line. Maybe it won't. So question number 8, suppose you have set the cruise control on a long car trip to 70 miles per hour. Below are several interpretations of the rate 70 miles per hour. Circle all that are correct or all that are equivalent to 70 miles per hour. Okay, so A, remember back to the last video that we did, I said per meant a fraction. So 70 miles per 1 hour. Yes, that's correct. That's the same thing as 70 miles per hour. B, 70 miles every hour. Yes, of course, that's the same thing. C, 17.5 miles in 15 minutes. Well, 70 miles per hour, that unit is miles and hours, and in this one, it's miles and minutes. So we need to convert 17.5 miles in 15 minutes to hours, or 70 miles per hour to minutes. Either one will get you to the same place. So let's do 70 miles per 1 hour. And let's see, let's break it down to minutes. So 1 hour is 60 minutes. I don't know why I wrote, okay, it should be equals. 70 miles per 1 hour equals 70 miles in 60 minutes. So then we go 17.5 miles over 15 minutes. And if we want to compare those two fractions, we need to get both bases or both denominators the same. So 15 minutes, how many 15 minutes are in 60 minutes? Well, you can divide it out if you don't know, or if you're really good at looking at a clock, you know that the clock is kind of broken up into 4 15-minute intervals. The 3, the 6, the 9, and the 12, that's all 15-minute intervals. Or you could just divide it out on your calculator because, well, it's there for you. So we need to multiply the bottom by 4 and multiply the top by 4 to see if it equals the 70 miles in 60 minutes. So we obviously know that the bottom is going to be 60 minutes because 15 times 4 is 60, which we just did. Then we need to multiply 17.5 times 4, and it equals 70 miles. So yeah, C is equivalent to 70 miles per hour. And then D, 70 miles, not equivalent, because in this one, miles is the only unit. They don't ever talk about hours. So no, this one is not equivalent. It only talks about miles. Part E, 315 miles after 4.5 hours. So now instead of 1 hour, it's 4.5 hours, and they've traveled 315 miles. So again, kind of like we just did, we need to convert these into the same units. So we have, I'll just rewrite it again, 70 miles per 1 hour. And we need to see if that will equal 315 miles in 4.5 hours. Well, for this one, both the tops are in miles and both of the bottoms are in hours. So our units are the same. So we don't need to do any converting like we did before when we went hours to minutes. They're both in hours. So we just need to get the bottoms the same. How do we get the bottoms the same? Well, 1 to 4.5. Hopefully you just multiply by 4.5. So we'll times the bottom by 4.5 and times the top by 4.5 and see if it makes an equivalent fraction. So 4.5 hours, multiply the top 70 times 4.5 times 4.5, and that equals 315 miles. So yes, those are equivalent to each other. And then the last one, F, is 1 mile in 70 hours. Well, if you just kind of think about this one logically, it's not really going to make sense. If this speed is going 70 miles in 1 hour, and this one is going 1 mile in 70 hours, I'm pretty sure all of us could walk faster than that. So no, this one is not equivalent to the others. All right, same thing for part 9. It is common for recipes and mixtures to use the term part instead of a specific unit like cup or tablespoon. A part is any unit of volume, such as teaspoon, cup, quart, or gallon. The person who creates the mixture can choose the units based on the amount being mixed. If we are mixing paint for a wall, a part could be a quart. If we're mixing paint for a canvas, which is much smaller, a part could be a 1 second squirt from the paint tube. So a juice recipe calls for 3 parts orange juice, 2 parts pineapple juice. And below are several statements. Circle all that are correct. So if you wanted to just make this drink for yourself, 3 parts orange juice, 2 parts pineapple juice, obviously the units that you're using are going to be much smaller than if you were making this same exact drink for a large party where you're serving multiple guests. So, let's see. So, A, for every cup of pineapple juice, you need 1.5 cups of orange juice. All right, let's see. So, we've got 3 parts OJ and 2 parts PJ is my original. And for this one, they're saying for every cup of pineapple juice, you need 1.5 of orange juice. So 1.5 parts OJ to 1 part pineapple juice. Are those equivalent? Well, let's see. Let's divide 3 by 2. Oh, that's not divide. And it equals 1.5. And then 1.5 divided by 1 is 1.5. Okay, so yes, those two are equivalent fractions. When I divided them both down and reduced them, they were the same. B, for every 2 quarts of pineapple juice, you need 6 quarts of orange juice. So I'm going to erase my work down here because the book doesn't really give me a lot of room to work with. So orange juice on top, pineapple juice on the bottom. So I need 6 quarts of OJ. I have no idea if it's quarts, but for today it is 2 quarts pineapple juice. Well, 3 divided by 2 we said was 1.5, and 6 divided by 3, or just give away the answer. 6 divided by 2 is 3. And those two are not equivalent. So B is out. When the juices are mixed together, the mixture is 3/5 orange juice. So when everything is mixed together, 3/5 is orange juice. So remember, this is part out of the whole because we're mixing it all together. So it's the part of orange juice compared to the whole entire mixture. And in here we have 3 parts and 2 parts, meaning that there's 5 parts total. So the whole is 5. And then we're mixing in just the part orange juice, which was 3 parts orange juice. So yes, this one was equivalent. The ratio of pineapple juice to orange juice is 2 to 3. Pineapple is 2. Yes. Orange juice is 3. Yes. So this one's equivalent. E. If you have 15 ounces of orange juice, you need to add 10 ounces of pineapple juice. So let's erase so that I have more room to see if this one is true. So we said you have 15 parts or 15 ounces of orange juice. So that means that you need 10 parts pineapple juice. Okay, well, let's reduce it down so that they're equivalent. If I want to get this 10 to a 2, I divide by 5, which would leave me 2. 15 divided by 5 is 3. So yes, those ones are equivalent. Whew. And the last one, if you use 4 cups of pineapple juice, you can make 6 cups of the whole drink. Okay, let's erase. Oops. Okay, so we're for sure using 4 cups of pineapple juice. Okay, so if I used 4 cups, that means I'm doubling the recipe. So 2 to 4 is times 2. 3 times 2 is 6 cups orange juice. Well, if I put 6 cups of orange juice and 4 cups of pineapple juice, I will have a total of 6 cups, which means that F is not equivalent because they're saying that I will make 6 cups of the drink, which is not true. Whew. Okay. Number 10, back to the nutrition labels. There are many instances in which we need to determine if ratios are equivalent, kind of like we just did. This is done by simplifying the ratio or scaling to see if one equals the other, which we just did. We just simplified ratios and we just scaled all at once, in case you didn't know. Congratulations. Question number 10. Most nutrition labels include suggested guidelines based on daily calorie needs, which is the same. This is the same little chart that we had back in the first example. This chart is the same on every single nutrition label. It doesn't change. Maybe they add a couple more daily recommended values, but otherwise all of those values are the same. They were submitted by, they're kept constant on every food label. So, A, create a rate that compares suggested saturated fat grams to total calories for a 2,000 calorie diet. Simplify the fraction. So we're using a fraction. We're going to have a part over a whole. And that means that we're going to have the suggested saturated fat grams compared with the total calories. All right. So the total calories is 2,000 because that's what they just told us we're using. And then we're going to go to suggested saturated fats, not total fats, saturated fats for a 2,000 calorie diet, which is just 20 grams. And this one was calories, grams of fat. Okay. We are going to simplify the fraction like they asked us to. So I'm going to go to my calculator. 20 divided by 2,000, and I get 0.1. But remember, we want this as a fraction. So I'm going to hit this little fraction button to the side, and bam, it reduces our fraction for us. Awesome. So 1 gram of saturated fat per 100 calories. If you're able to reduce that in your head by yourself, more power to you. If you weren't, just use your calculator. Part B, create a rate that suggests saturated fat grams to total calories, this time to a 2,500 calorie diet. Again, simplify your fraction. So once again, I'll have part over a whole. I'm not going to write it again. That compares saturated fat grams to total calories. Not going to write that again either. But I am going to write that the suggested is 25 grams for the 2,500 calorie diet. So 25 grams of saturated fat per 2,500 calories. Again, if you don't want to simplify that in your head, go ahead, plug it in your calculator, you get your little decimal, turn it into a fraction, and it's the same fraction. 1 gram of saturated fat per 100 calories. Compare your answers from part A to part B. What do you notice? Well, I notice that they're the same once you simplify. And if you're like, wow, Miss Sanchez, that's some chicken scratch you've got going on there. Yes, I realize I'm getting kind of tired of taking these notes. If you can't read my notes, look at the answer key for some beautiful handwriting. Okay, interpret the new simplified rate in words. So taking this fraction, interpreting it into words. I'm not actually going to write this out. Go ahead, look at the answer key. I'm just going to read off the answer right from there. It is suggested that a diet should have 1 gram of saturated fat for every 100 calories that you eat, regardless of the total calorie intake. So no matter how many calories you eat in a day, whether you eat 100 calories in a day or 10,000 calories in a day, not that either one of those diets is recommended by anyone, but no matter what your diet is, 1 gram of saturated fat for every 100 calories. All right. A good easy review on proportions right here. If you need help on converting fractions, we kind of just did it it was in the last video. That's what I was doing. I was converting the fractions. Review if you need to, or look back to for help if you get stuck on anything. We are going to go to question 11. Nutrition guidelines suggest that we consume 25 grams of fiber for a 2,000 calorie diet and 30 grams of fiber for a 2,500 calorie diet. Is the suggested amount of fiber proportional to the number of calories? Is it almost proportional? So we've got two proportions, 25 grams of fiber for 2,000 calories and 30 grams of fiber for 2,500 calories. And we need to determine if they're proportional or almost proportional. So we'll set up those two proportions. So 25 grams of fiber per 2,000 calories and 30 grams of fiber per 2,500 calories. And as always, I'm not going to do the math in my head. So we get 0.0125 grams per calorie of fiber. And 30 divided by 2,500 gives us 0.012 grams of fiber per calorie. And I would say that those are almost proportional. The proportional, the decimals are pretty close to each other, just fractionally off. So I would say almost proportional. Part B, approximately how many grams of fiber should be recommended for a 3,000 calorie diet? And we're going to use that same recommended proportion. And your answers may vary depending on your setup and which proportion you used. So whether you used the 25 grams of fiber for 2,000 calories or 30 grams of fiber for 2,500 calories. I'm just going to use the 25 grams of fiber per 2,000 calories. And I'm going to set up a proportion to find out how many grams of fiber, so X, how many grams of fiber I need per 3,000 calories. And then to solve this proportion, I'm going to cross multiply. So I'll get 2,000x equals 25 times 3,000. 25 times 3,000. So 2,000x equals 75,000. And then we'll divide that by 2,000. And we get X to be 37.5. So they're saying, based on the proportion that I set up, yours could be different if you used the 30 grams of fiber. But it's recommended that you get about 37.5 grams of fiber if you eat 3,000 calories. Perfect. Part C, I'm going to skip. Part D, I'm also going to skip. I think that they're pretty time consuming and this lesson is getting long enough. I do want to take a quick look at this sticky note. If you are struggling with a math problem, it doesn't necessarily that something is wrong. You will have many challenging problems throughout this course that you will often be expected to work through without someone teaching you first, which is so true because I'm not next to you. I'm teaching you virtually. I am an email away, but I'm not just a little hand raise away. Learning to work through these challenges helps you develop perseverance, which will pay off in math, your college courses, and in your future jobs. Okay, so I know some of these problems are rather challenging. These problems are long. They are tedious. I'm already exhausted teaching this. So I know that most of you are probably exhausted trying to figure out this math as well. But you've got this. And then this last question, I think, is a really interesting problem, especially all that's been going on this summer with Black Lives Matter. So, question number 12, last one. According to the U.S. Department of Justice, from 2003 to 2009, there were 2,931 deaths related to police arrests. Of these deaths, 41.7% were white and 31.7% were black. If the U.S. population of approximately 322 million is approximately 63% white and 13% black, are black people disproportionately likely to be killed by police? Are more black people than white people killed by police? Fully explain your reasoning and include the number of white people and black people in the population and in the death count. Okay, so this problem has a lot going for it, But I think it's such an important question to look at related to deaths from police arrest and other issues going on when we're looking at proportions, because sometimes when we're looking at proportions, they're very easily skewed to make people think one way when they're not actually doing the math behind it to see if they really are proportional. So just straight looking at this, 41% of police deaths were white and 31% were black. It looks like more white people are being killed than black people. But then we add in the population where 63% are white and 13% are black. And now we kind of see, there might be something disproportionate here. So I'm going to split this into two columns. We will look at the number of white people in the U.S., the number of white deaths, the number of black people in the U.S., and the number of black deaths. And then we'll compare those proportions. Okay, so we've got the number of white people in the U.S., and we said that there was 63% white. So we'll go 63% of the total population, which was an approximation at 322 million. Of 322 million. Okay, and then I think I'll need to move this over so that I have enough room for everything. Okay, then we have the number of black people in the U.S., and we are told that there are 13% of the 322 million. So 13% of 322 million. All right, so if we do the math, plug it in our calculator, we get 202,860,000 people. And over here we have 4,186,000 black people in the U.S. Okay, now the other bit of information that we were given was the percent of police-related deaths. And they're saying that, let's change colors. So of these deaths, 41.7% were white, 31.7% were black, of the total 2,931. So let's take a look. We have number of white deaths related to police arrests. We have 41.7% of 2,931. And then the number of black deaths related to police arrests was 31.7% of the total 2,931. Okay, so we do the math, and we have 1,222, and we have 929. Okay, well, it still looks, when we did the numbers, it still looks like we have more white deaths in the U.S. Okay, but is this proportional? Now we need to create a fraction of the number of white deaths to the total the total number of white people in the U.S. and to proportion the number of black deaths to the total number of black people in the U.S. So we're going to have the 1,222 divided by, I don't want to write this again, so I'm going to circle, copy, paste. Okay, and then 929 divided by, again, I don't want to write it again, so copy, paste, there we go. So we've plugged this into our calculator, we get 0.00006, which we need to then turn into a percent. We get 0.0006%. And if we plug this into our calculator, we get 0.00022, which is 0.022%. Okay. So now take a look at these percents. Definitely no longer proportional. Okay, so we need to explain our findings. So, yes, in fact, more white people are killed by police. Just looking at the numbers, we've got 1,222 white deaths by police arrests versus 929 black deaths due to police arrests. Okay? But when we compare the percents, and I'm not going to write this down just so we can finish the video. When we compare these percents that I highlighted, black people are disproportionately killed by police. The percent is a lot higher for black deaths versus white deaths by police arrests. Okay, so when looking at numbers and data, it is important to make sure that your data is proportionate before you start comparing them.